the problem, okay, starting with a rectangular lot that refer to this lot, like over here. Okay, fence on 3 sides, and an adjacent building forms the 4th side. So this one we don't have to do the fence, just against the building. If the total length of the fencing is 48 feet, write a function that represents the area of the rectangle. Determine a good viewing rectangle and graph the function. So don't worry about the last part here. Once you get the model, you can use the calculator to plot it. But after we're done, I'll show you real quick what does it look like. So overall, you are going to write a function that represents the area. That's your goal. Okay. Typically, the area notation, we use the letter A. Okay. The A as the area of the rectangle. And do you recall the formula to find the area of rectangle?
Length times width.
Length times width, very good. So I'm going to put here is length multiplied by width. And based on the diagram, we have the restriction that the fence, the length going to be 48 feet. And we have 2 fences, just 3 sides, not all 4 sides. What are we missing here? We are missing the unknown, or the notation that we can use to form the equation. And based on the formula that you told me is length times width, how about we name the unknown variable to represent length and width? Could anyone share with me what would you like to represent the length and the width? I mean the notation, the unknown notation to represent the length and the width.
Oh, X.
Would you like to use X and Y, or
Just X.
just X? So what would you like X to represent?
For the
For the width.
Yeah, for the.
Okay, so I'm gonna put the note here. So let X represent the width. If X represents the width, I'm gonna put the notation on the diagram. So put X here. The opposite side would be the same, correct? Now we have 2x, but with the condition that the fencing is 48 feet, how do we use the number 48? That means when you measure from this side to this side and to this side, overall must be 48 feet, correct? If you already assign x as a width, we have 2 x's over there. That tells you the rest of them here, it must be the rest of the 48. Okay, it's going to be 48 minus 2 x's.
Right.
You guys with me?
Yeah.
So I'm going to put on the note here. So 48 minus 2x equals the length. So now I can bring everything back to the equation or the function that we are looking for. So our A, or the area, based on length times width, the length is 48 minus 2x and multiplied by the width, which is x. I have the expression as we simplify, we have 48 multiplied by x minus 2 times x squared as the function representing the area of the rectangle that we are looking for. So this is the answer. Okay. This part is done. But for the later part that I told you not to worry about for a moment, we're gonna determine a good viewing rectangle and graph the function. So from this one, you can see x can be adjusted, depends on the dimension that you want it to be, right? For the graph of 48x minus 2x squared, as you notice, you have the power 2. You could suspect the graph gonna be the parabola graph, and it's upside down because you have the negative side. So we expect to have the graph that looks like that. If you plan to do it by hand, it can be done too. Probably you don't prefer to do that by hand. As you see the intercept for the area to be 0, that means x gonna be 0. You see here, x gonna be 0, or x gonna be 24. So you get two intercept here, 2 and 24, and the graph as a parabola. That means the x could be anywhere between 0 and 24. And the height here, the height is the area or the possible area that would occur. So for the choice of 0 and 24, that would not be a good choice to get the area because you're going to end up with the 0. But you could get something in between that give you the maximum height, which is the maximum area. So that is the adjustment when you work on the model. How would you like to make a measurement? Like you could get like something like this, a small x, or you can get like very large x, but very small length, something like that. So that would be the possible option for you to make it fit whatever that you have or the restriction that you have.